All right, this is our last lessons of this chapter 4. We're going to do lessons 6 and 7 because they're just the same kind of problems, just extra examples. So here we go. Carmen is a surveyor who is using a transit to determine the height of a tree. The transit is placed 52 meters from the base of the tree, and the angle to the top of the tree is measured to be 12 degrees. If the transit stands 1.8 meters high, calculate the height of the tree. All right, so we're just going to use everything we've done before. We just have this extra little piece right here that we have to talk about when we're done. All right, so we're going to find the height of the tree. We're going to call this X over here, and we're going to go, that's opposite, and adjacent, which is tangent. Tangent of the angle is equal to the opposite over the adjacent. We do the math. We get X to be 11.1, but that is from this part of the tree, right? And we're supposed to add in this little piece. So we just go plus 1.8, and we get 12.9 meters. Okay, so just that little extra step at the end, just clarify, make sure you're reading the question. Then it says determine the angle of the base of the transit. Determine the angle the base of the transit makes with the top of the tree. So we would have to go down to 12.9. So just do a new triangle, I would say. Okay, so this is 12.9. We have to do the whole tree. And because we're talking about the base of the transit. So we got to go all the way down to the bottom. So draw your own. This is still 52. We're doing the whole tree measurement of 12.9. Do the math, and you will get tangent of, if I call this, I don't know, what, A. Tangent of A is going to equal 12.9 over 52. Second function is looking for the angle, and you would get to the nearest degree, 14 degrees. All right. Class example 2, circle, oh boy, circle with a radius of 20 millimeters is tangent to the arms of the angle at POQ. Hey, you guys, I don't know if you remember this, but when you have an angle, a tangent line and a circle, that means they touch in one spot. So a tangent line to a circle touches in only one spot. What we know about that from I guess grade 9, is that the lengths of these triangles are the same, or these angles. The length of the tangents, the length of a tangent from an external point to a circle, they're always equal in length. So those two lengths are equal. Then it says if angle POQ is 50, so we're going to make this 50. Determine the length of OC. Oh my goodness. So now check this out. There's another rule that says a tangent to a radius. Here's your tangent. Here's your radius. That is a 90 degrees. Pretty cool, huh? So a tangent to a radius equals 90 degrees. That's another rule that we learned in grade 9. All right, so the radius was 20. I'm going to put 20 on there. And this whole angle POQ was 50, so I just cut it in half, which makes this 25 right there. And I want to find the length of OC. So this will be the hypotenuse, by the way. So you have this picture. I could draw it out a bit bigger. This is 20. This is 25. And you're looking for this length here. I'm going to call it X. Okay. So we have the 90 up here. We have the opposite. And we have the hypotenuse. We're going to use sine. Sine of 25 is equal to the opposite over the hypotenuse. You're going to cross multiply. You'll have to do division there, and you'll get OC to be 47 millimeters to the nearest whole one. All right, so some little rules about circles there you'll have to remember. All right, 242, here we go. It says, in the many problems, the angle of elevation or depression is determined from the person's eye level and not from the ground. So it's a good thing to look at. It says in the diagram, the man on the ground is 12 meters from the wall. So we got to put 12 meters there. The angle of elevation from his eye level to the eye level of the wife is 62. If the man's eye level is 6 feet from the ground, so this part here is 6 feet from the ground, above the ground, his wife's eye level is 5.2 feet from the top of the building. Oh my word, there's so much details. Okay. His wife is 5.2 from the, oh, wait, sorry. His wife's eye level is 5.2 from the top of the building. So this length here is 5.2, right? Okay, determine the height of the building to the nearest tenth of a foot. So we are going to go find this length here. Okay, we're going to find that, and then we're going to add I'll make it yellow. We're going to find all the extra pieces that we'll need to do that. So this is the opposite, and that's the adjacent. So we're going to say tangent of 62 is equal to the opposite, I can call it x, over the adjacent. Cross multiply, and you get x to be 22.56. Now don't, some other stuff there, don't stop. We're going to go to the nearest tenth of a foot, but give some extras until we get to the very end. Now we need to know, so we know that that is 22.56 here. So now I have to add the 6 feet off the ground, this part. And then I have to add the 5.2 at the top. So when you're all done, you'll get 33.8. That's the height of the building. Okay? All right. This bearings thing is a new deal that you might not have heard before. This is how my husband does his aviation stuff. Okay, so this is a new idea, a new concept. It says a bearing is an angle measured clockwise from the north direction. Okay, so we always draw the north line, and then you go clockwise this way, 150. So 225, you first start with your north line, and you go all the way around to 225. 330, of course, all the way around is 360, so not quite there. All right. A boat is on a bearing of 40 degrees, so you would plot your north line, and then you go 40 degrees. All right. So on class example number 4, it says a ship travels 6 kilometers from a port P on a bearing to 120 degrees. Okay, now this gets complicated, so pay attention. There's P on a bearing of 120 degrees. So you plot your north line and you go around to 120. All right, to position Q as shown. The ship changes direction at Q and travels north, straight north. Okay, so at Q, it goes north until it reaches position R, which is due east of P. Like this. And this is R. Due east means that there's going to be a 90 degrees there. How far east of P is the ship at position R? This is the part we don't know. How far is it from P to R? All right. Do we know anything? Okay, go back. A ship travels 6 kilometers from a port P. This is 6 to position Q. Okay, now I really, really, really need this part. Well, here you go, folks. This is 90, but the whole thing is 120, so this must be 30 degrees, the little blue. All right, so now, as soon as you have your picture, life is good. I'm looking for the adjacent. I have the hypotenuse, so I'm going to go cosine of 30 is equal to the adjacent over the hypotenuse, cross multiply, and you'll get x is 5.2. Okay, that's how far it is from R to P. I could call this kilometers here. Okay. Now let's go on. The ship continues traveling north for a further 12 kilometers. Okay, I'm going to put this in here first. I'm going to erase the X now and put 5.2. Okay, let's go back. It says the ship continues traveling north for a further 12 kilometers to position S. So it keeps going. Whoa. 12 kilometers to position S. Determine the bearing of S from P. So draw your line from P to S. And I need to know the bearing there. So if you're looking for the bearing from P, I need to find this. It's not 90, it's not 30. I don't really know. The 120 was the red line. I need to find that. So I'm going to call this, let's call this Y. Okay, I am looking for Y. I don't know the rest of it the way it is right now, but let's think about what we could do. Oh, okay. Do you see this? Shh. Do you see the Z on it? This armpit is the same. This is also Y. Because if you have two horizontal lines cut by a transversal, the Z, the armpits of the Z are the same. So my Y's are the same. So all I really have to do is go figure out what angle Y is. I'm going to draw you a new picture. I want you to understand what we're doing here. This is Y. Here's 12. This is 5.2. And I'm looking for Y. So I'm going to do, this is opposite. So tangent of Y is equal to opposite over adjacent. So we're going to go second function tangent right there, 5.2 over 12, and all of a sudden Y is going to be 23 degrees. So this is 23, which means this is 23. All right, next question. If the ship maintains an average speed of 9 kilometers throughout the journey, determine to the nearest tenth of an hour the time taken for the journey. Okay, so we need to figure out, we know this is 6. We need to find this path, okay? He goes from P to Q, then he goes north, and then he goes a little further. So we have the 6 and the 12. We just have to find the one other spot, which is this piece here. Let me call this little p. If we could find that, we would go 6 plus 12 plus, we're looking for little letter p in there. So let's go down here. We'll use our 30. We have this triangle. I can draw it again. This is p, this is 6, and this is 30. So opposite and hypotenuse. So let's go sine of 30 is equal to opposite over hypotenuse. And you'll end up with P to be 3. So all we have to do is 6 plus 12 plus 3 is 6, 9, 12, 21. All right, now we know how far he traveled. He traveled 21 kilometers. Now, that is not what the question said. It said, how long? If he goes 9 kilometers per hour, how long does it take to make his journey? All right, so we're just going to go, there's lots of different ways. You can go distance over speed. We can just go 21 and divide that by 9, and you'll get 2.333, but to the nearest tenth, we can go 2.3 hours. So just answer that one little question when you're done. All right. I'm now going to switch over to lesson 7 and just do 2 more examples and we'll be done. Okay. So sometimes we have 2-dimensional problems. So you just have these, we're going to have these 2 triangles. You're going to solve one of it. So it says in the diagram, QS is 32. Fill in everything you can. PQS is 50. And angle RPS is 61. Use this information to determine Q to R, the whole thing. All right. You do not have enough information. Q to R, you are going to need to find this part. So we can add 32 and X. You can't find that. So it's going to take quite a few steps. I don't have enough information to find X. If I look at only the right-hand side, I might have some information to find an unknown side, because if I look at the left, I do not have enough information. Remember, I need 2 out of 3 pieces, and I only have 1 piece in the blue triangle. So how about we go find the side that is shared by both? I'm going to call it little q here. If I find little q, then I would have information that could go from the PQS triangle, the yellow one, to the blue one. So I'm going to go find angle q, little q. So I'm going to say sine of 50 is equal to the, not sine, sorry, let's make it tangent, because we have opposite q over adjacent, which is 32. So it's going to take a few steps. Cross multiply, you get q to be 38 point, don't round yet, 0.13, and there's some more information there. All right, so then I now know what this q is. It's 38.13. So now I can use the blue triangle and find X. So it's opposite and adjacent again. So tangent of 61 is equal to opposite over adjacent. And when I do that math, I get X to be 68.79 and some more stuff. Find the entire length, add 32, and you will get 101 to the nearest millimeter. So 2 steps in this process. Move from what you know to get help on what you don't know. Go from the side that you can find information to find usually the shared side. Calculate the measure of BEC, this one, to the nearest degree. I do not have enough information. In this triangle over here where BEC is, I do not have enough information. But look about the yellow one. Do we have enough to find a shared side? Yes, we do. If I go and find this side, I'm going to call it X. That's this length here. That's shared by both. Then I would have 2 pieces of information and I could find the third. I'm going to start with the yellow triangle. I'm going to use 39 degrees. Opposite and hypotenuse is sine. Cross multiply. And all of a sudden, X is 2 point. Give yourself quite a few decimals on there. All right, 2.328. Now I'm looking for this angle E up here at the top. So I'm going to go adjacent and hypotenuse, which is cosine. Cosine of, I'm going to put angle E like that, is the adjacent, whatever you have in your calculator, divided by 4.6. This will require you to go second function cosine to get E. This big stuff. And when you're done, to the nearest degree, angle E is 60 degrees. 2 steps. Go from what you know to what you don't know. All right. Question 250. I'm only going to do this one last problem. It says in January 2003, the tallest building in Rockyville was the Metro building. Recently, a developer was commissioned by the Gamma Pro Oil Company to build a taller building next to the Metro building. From the top of the Metro building, the angle of elevation to the top is 24 of the opposite building. So this is 24. The angle of depression, so from the horizon down, is 56. That fits here. If the buildings are 45 meters apart, so across the bottom, we're talking 45 meters in between. You can put that wherever you want. I could put it up here as well. We're supposed to find the height of each building. All right, so there's a couple of things to do. We need to find this piece. Let me call it X. And then we need to find this height. That would be the Metro building, and together they would make the Gamma Pro building. So we need to find those. So if I just use this triangle here, let's color them up again. Let's find the yellow triangle information and find Y. So I have an angle, I have one side, I need to find the other side. So it's the opposite and adjacent. I'm going to use tangent of 56. It's equal to the opposite, which I don't know, over my adjacent. You do the math. Tangent of 56 times 45 gives you 66.715. Okay, now let's go find X. I need to find X. I have the 45, opposite and adjacent tangent again of 24 this time is equal to the opposite over the adjacent. And tangent of 24 times 45 gives you X to be 20.035, etc. Okay, so I could say the Metro building was the 66.715 right there. And the Gamma Pro would be what I had in X. I would have to add the 66.715. And you would get 86.75. But I'm supposed to go to the nearest meter. So I better change this one to 67 meters. And I better change this to 87 meters. Not millimeters. And this was the Gamma Pro. Okay, good. I'm going to skip the next question. It's quite complicated. Actually, maybe I'll just do the first part here. This is like a block of cheese. Okay, this is the three-dimensional building. You have to do a lot of work. I just want to show you one step that you can do. HD is 5. EA and FB are both 2. And AD is 6. Well, shucks, I missed something. Oh, sorry, the 2's in the wrong spot. EA and FB are the little short sides. This is 2. And A to B is 8. Okay, so name for rectangles. There's lots of different rectangles. There's the front, the back, the top, and the bottom. Okay, so there's those sides. But I'm going to skip to part B that says calculate the measure of HEA. I'm going to draw this side. What's so important about this is that you take this wedge and you draw it sideways to help you. So when you draw it sideways, it's going to look like this. This is long, this is short. Comes across and this slants, right? This was 5 and this is 2 and 6. This is H. I'm just taking that blue and I'm turning it sideways so you can see it better. Okay, I'm supposed to find the measure of HEA. That's all of this. You guys, the quickest thing to do is to draw a line across here, which makes this 2 and this a 3. It's not drawn to scale, let you know that. This purple part is 90 degrees. This is 90. So really I need to find this measurement and then add 90. By the way, if this is 6 here, then this is 6 here. So now I have a triangle that is 3, 6. I'm supposed to find the little slice, the little blue angle here. Maybe I'll call it X. I'm going to use tangent of X is equal to the opposite over the adjacent to second function, and X is equal to 26.56. And some change. I'm going to then add the 90 to get the whole thing to the nearest degree. 117 degrees, all said and done. So what was important was to cut that blue slice, turn it sideways so you can see it good, and draw this purple line to divide it so that you have a rectangular shape down here that's 2 by 6, leaving you what's left in the other little triangle on the top. Okay, that's as far as we're gonna do. I'll give you some questions.